Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about how to use the zero order, first order, and second order kinetics equations. Okay. In the last video, we decided on how to figure out which equation to use. In this video, we're actually going to use all three of these using the following givens. Okay. So in all three of these problems, the givens are going to be exactly the same. I'm going to give you the initial amount as 10, the time is 6 seconds, and the K is equal to 0.50. And our job is to figure out what is the concentration at time equals 6 seconds. So I'm going to solve for this one, and this one using the same givens over here on the right-hand side of the board. So let's get started with using the zero orders kinetics equation. Okay, so once again, the variable that I'm trying to solve is the amount at time equals t, which is going to be 6 seconds in this case. So this is what I'm trying to solve for. The initial amount is going to be 10 molar, so we know this number is going to be 10. K is equal to 0.50, and the time is going to be 6 seconds. Okay, so I'm not going to include any of the units here because the units change depending on if it's zero order, first order, or second order kinetics. Okay. So here we go. Really, this is quite simple. All I'm going to do is multiply these two numbers together, and 0.5 times 6 is going to be negative. That's going to be negative 3, right? Negative 3 molar. Okay, and that's going to be equal to negative 10, and the amount at time t. Okay, so I'm just bringing the plus 10 to the other side. So the amount at time t would be 7 molar. Okay. So if I bring this 10 over, a plus 10 and a negative 3 is 7. So the zero order kinetics one is actually pretty simple to use. Okay, it gets a little bit more challenging with the other two. Okay, so same situation. Okay, I know this, and this, and I'm trying to solve for the amount at time t. Now this deals with natural logs, and this tends to give students a little bit more trouble when solving this equation mathematically. Okay, if your math skills are good, maybe not, but if your math skills are that's a little shaky, maybe this will be good to look at. Okay, so we got natural log of the amount at time t minus the natural log of the initial amount, which was 10, and that's equal to negative k, which is 0.5. Okay, and we're going to multiply that by 6 seconds, right? So once again, 6 times 0.3 or 0.5 is going to give us negative 3, okay? And natural log at the amount of time t. And I'm just going to go to my calculator. I'm going to include what is the natural log of 10, okay? And that ends up becoming, the answer ends up becoming 2.3, okay? I'm going to bring this to the other side by adding 2.3 to both sides. So this becomes the natural log of the amount at time t, which is equal to negative, and I carried everything out. It's going to be negative 0.697. Okay, so this was probably 2.3 something something. And when I bring that to the other side, I get this number of negative 0.697. This is typically where students get a little bit stuck, okay? How to figure out this part, because I don't want to know what the natural log of the concentration at time t is. I want to figure out what is the concentration at time t. So what I have to do on both sides of the equation is I have to go base E. Okay, so if I do base E on this side, that's what gets rid of the natural log, and it becomes the amount at time t. And of course, what I do to one side of the equation, I have to do to the other. So I have to go base E to the negative 0.697. Okay. Now, the way you insert that into your graphing calculator, okay, is you're going to come in here and hit the second button, and then you're going to select natural log, and that's going to give you your E number. And I need to take that to the negative 0.697. Okay. And when I do that, I get my answer of 0.498. Okay, so that sometimes gives students a little bit of trouble of using base E. And just remember, you hit the second button, okay, and then you hit your natural log button. That gives you your base E, and that might be different based on your calculator, okay, but on my calculator, that's how it works. And then you will get your concentration at time t to be equal to 0.498 molar. Okay, so if we had a problem that was first order kinetics, we would have to use this equation, and this is what we would get from those givens, which is different than if it was zero order kinetics. So trying to figure out if your problem is zero order, first order, or second order kinetics is a qualitative piece that you need to figure out before you start doing this quantitative piece of actually calculating it, okay? So the last thing that we want to calculate quantitatively is second order kinetics. And it works exactly the same way. I'm just going to start plugging the numbers in. Okay, so we got 1 over the amount at time t is equal to 1 over 10, okay? And that's equal to positive k, which is 0.50, times my 6 seconds, okay? Of course, when I multiply these out, it's going to be equal to 3, right? Okay, and this 1 divided by 10 is just 0.1, so this is negative 0.1, and that's going to be 1 over my concentration at time t. I'm going to move this to the other side, so I'm going to be adding 0.1, so 1 over the amount at time t is going to be equal to 3.1, okay? And then what I want to do is I kind of just want to do some cross multiplication. So if I cross multiply, I can bring this one down and this one up, okay, if you are okay with that. So this actually becomes 1 over 3.1 is equal to the concentration at time t. So I just kind of flip-flop these using cross multiplication. If you want to think of this as 3.1 over 1, you know, doing the cross multiplication can work, okay? And then, of course, when you put this in your calculator, 1 over 3.1, okay, which is inverse concentration, we get 3.23 as our answer, okay? So 3 different answers based on 3 different equations, okay? And once again, okay, sometimes the hardest part of doing all this chemistry stuff in kinetics is trying to figure out, do I have something that is zero order, first order, or second order kinetics? And sometimes that's done qualitatively, sometimes that's done quantitatively, but after you determine which order kinetics it is, you have to use this equation if it is zero order kinetics, and you'll get this answer, okay? But if it's first order kinetics, okay, for the problem, then you'd have to use this equation and you'd get this answer. But of course, if the problem was second order kinetics, okay, you'd have to use this equation to get this answer, okay? So sometimes, like I said, the hard part is trying to figure out which type of kinetics it is, and that was explained in the previous video. This video is just getting comfortable mathematically using these different types of equations. If you found this content helpful, please give it a like and subscribe, and when you leave a comment, it pushes this stuff out to other students that might be interested in learning chemistry.